This video is going to discuss one of the equations we talked about in class, and that is E equals mc squared. And this problem is going to allow us to calculate if we have a penny with a mass approximately of 3 grams, and if we could take all that mass and somehow convert it into energy, how many joules of energy will we get? So one piece of information given to us is the mass in grams, and we will actually have to convert that into kilograms. The other piece of information that we need to know is the speed of light, which is 3 times 10 to the 8th meters per second. Without scientific notation, that would be 300 million meters per second. So the first step is we have to convert grams into kilograms. To do this, we need to know the relationship between grams and kilograms. So 1 kilogram is equal to 1,000 grams. Now to convert this, we're going to use the technique that we discussed in class. There are many videos on how to do this on YouTube, and I may make a video in the future. So what we have to do is we have to get rid of our gram units. So the 1,000 grams will go on the bottom, so we can get rid of the grams. Now we're converting to kilograms, so the 1 kilogram will go in the top. Now what we're going to do here is just do order of operation. So 3 times 1 is 3, and divide that by 1,000. And if you put that into the calculator, you get 0.003 kg. And that is from the units being left over. From the previous step, we converted grams into kilograms. And now what we need to do is plug everything into our formula. Now, to plug everything into a formula, first of all, we have to talk about units. So mass will be in kilograms. C, Celeritas, is speed of light, a constant, has units of meters per second. And if we use our KMS units, and KMS units say that all our units are kilograms, meters, and seconds, which they are, the energy will be in a unit called a joule. Now, a joule you've probably never heard of, but if you have a light bulb, a 100-watt light bulb is equal to 100 joules of energy being used every second. And the way to spell joule is like this. So since we have kilograms, meters, and seconds, our energy from the problem will be joules. This is not a unit that you are accustomed to. Other units, foot-pounds for English, are BTUs. To finish the problem, we just have to plug our knowns into our formula. So we have 0.003 kilograms. We multiply that by the speed of light, and we raise that to the second power. Now from this, whatever answer we have, we know that the units will be in joules. We can use our calculator to solve for the energy. To do this, we can use a calculator, scientific calculator. This is a little bit different in class, but the keys are basically the same. So we have 0.003. And we're going to multiply that by 3 times 10 to the 8th meters per second squared. So we have to use parentheses. Now there's 2 different ways to do this. You can use the EE key, which actually has times 10 to the power in it. I'm going to use the times 10, and I'm going to raise it to the power of 8. And I'm going to close the parentheses, and we still have to raise it to the second power. And we will get our answer. And our answer is going to be 2.7 times 10 to the 14th power. So on the calculator, you could have done it a little bit shorthand. You could have gone 0.003 times, hit the parentheses, 3, and this does the times 10 to the power for you. And we raise that to the second power. Now with this answer, we have to leave in scientific notation. If we wanted to write it in decimal form, we would have to take that decimal and move it over 14 places to the right. So I'm just going to write it out to show you why we use scientific notation. And this would be our value. So if we have a 100-watt light bulb, we'd be using 100 joules per second. So this amount of energy, if we could take a penny and turn the mass into energy, would be of times 10 to the 12th larger in magnitude. Some students may have different calculators, and the big difference for a lot of the calculators is what key they use to raise something to the power. Now, I refer to this as the caret in class, and a lot of the Texas Instruments use this key. Now, other keys to raise to the power using exponents, some calculators will use x to the y or y to the x, and some of the new calculators as well. I've seen x with a box. So if your calculator has one of these keys, you'll need to use that to raise it to the power.